Okay, so starting with today's topic, okay, we're going to be getting more into what the bulk of this organic kind of week is about, okay, and that is how we name hydrocarbons. So there is actually a system put in place by what's called the International Union of Pure and Applied Chemistry. So they basically oversee all naming and classification of chemicals, okay, so that we all can get on the same page about what we call them, so that I don't call propane barbecue juice and you call it uh, fire gas, right? Because then we don't know what each other are talking about, right? So it's very important that we all call them the same things and that we're all on the same page about it so that we don't mix these often dangerous chemicals up, right? So the IUPAC came up with a system to name hydrocarbons. That's what we are going to start to do today is break apart that system and learn how the name of a chemical tells us a lot about its structure. So we're going to go through that system now, okay? So everything in the name of a hydrocarbon is useful, okay? There is no part of a hydrocarbon name that doesn't tell you something about the molecule, okay? The first thing that we're going to look at is actually the ending of the hydrocarbon, okay? So we have things called alkanes, alkenes, and alkynes, okay? Alkanes, alkenes, and alkynes, okay? So an alkane has only single bonds. So if it ends in ane, it has only single bonds, okay? So this guy, hey, we just drew this on the last page. Ethane. Notice, looking around, do you see any double bonds on the carbons? Nope, only single bonds, right? So only single bonds, so it ends in ane, okay? Ethane would be this one. We'll get to the F in a second. This is just an example. Okay, alkenes, you guessed it, they have a double bond. Okay, so alkenes, if it ends in ene, see how this is ethene? It has a double bond somewhere, right there. Okay, so alkene has a double bond between some of the carbons. What do you think an alkyne is going to be? Okay, an alkyne has a triple bond between the carbon atoms. So when we look here, this is ethine. Ethine because it has a 1, 2, 3, a triple bond. Okay, hey, quick question for you. Which one of these is unsaturated and which ones are saturated? Remember, saturated means single bonds only. So this guy would be saturated. Do these two have single bonds only? No, so these are both unsaturated. Okay, that goes for all alkenes and all alkynes. So these are just examples. One's called ethane. F actually means two. We'll get to that. Ethene, two carbons, but with a double bond. Ethine, two carbons, but with a triple bond. Okay, so a quick trick to help you keep this straight, although honestly on page 9 of your notes, they kind of have examples that help you with this as well. But a trick I use is that in alphabetical order, it kind of goes 1, 2, 3, right? So I think A, B, C, 1, 2, 3 in my head. So ane is what kind of bonds only? Single bonds only, right? Single only. What's next in the alphabet out of A, E, and Y? It's ene, right? So ene has a double bond somewhere in there. Whereas ein, Y is almost the second last letter in the alphabet, right? Ein has a triple bond in there. So see what I mean by alphabetical order? Ein, ein. Hey, that's in alphabetical order. So alphabetic. And then this goes basically from, so single, double, triple is kind of like 1, 2, 3, right? So 1, 2, 3. So I think of it as A, B, C, 1, 2, 3. In alphabetical order, we have ein, ein, and then we have single, double, triple. So A, B, C, 1, 2, 3. Okay, then on, like I said, a lot of this is in your data booklet. So I want you now to please open to page 9, okay? Page 9 of your data booklet. So on page 9, you will have both of these things, okay? These will both kind of help you out when you can't maybe remember what the rule is for naming something. So you might know the rule, but you can't remember, oh, does meth mean 1 or does meth mean 2? Okay, so first we have here this thing. This is kind of at the bottom half of page 9. All we'll use in Science 20 are these top 3, okay? But if you're saying, oh, I can't remember, if you can't remember the ABC 1, 2, 3 trick, you go, oh, was ane a double bond or a single bond? Well, look, they have examples for you here. So if it ends in ane, okay, or ethane, hey, look, that's only single bonds. Ene, okay, that means there's a double bond, right? Or ein, oh, right, that means triple bond, okay? So it is all there for you. The next thing we're going to get to, the next part of the name that tells us something. So, hey, methane. Remember, I said there's no part of the name that doesn't tell us something about the molecule. Guess what meth tells us? Well, if you look here, meth has 1 carbon. Okay, anything that starts with meth has one carbon. Remember those ones we were just looking at? They were all ethane, ethene, and ethine. The number of bonds was different from carbon to carbon, but notice what's the same in all of them? They all have two carbons. So guess what F means? F means that the chain has two carbons in it. Okay, so you'll notice here FC2. Okay, prop means three carbons. Bute means four carbons. Pent means five. Okay, hex, hept, oct, non, dec. Okay, so that's all that means. These prefixes, this part of it tells you how many carbons are in the chain. Now, these all are for alkanes, right? So this would be methane. What kind of bonds would be in methane? Would you find any double or triple? Nope. What do you think about ethane, propane, butane? So these are all the versions of those hydrocarbons. This has one carbon and no double bonds. This has pentane has five carbons and no double bonds. Hexane six. Okay, they're all the anes. So you could have propene, right, where there would be double bonds, or even propyne, where there would be triple bonds. But the prop part still means that there are three carbons in there. Okay, so this will help you remember how to name based on the number of carbons in the chain. Okay, let's just quickly go through all the rules and then we'll do some practice with these unbranched hydrocarbons. So what do we need to do? First things first, locate the longest continuous chain of carbons, okay? And then we're just going to find the prefix that matches that number of hydrocarbons, okay? So for example, if it had one in its chain, we would start with meth, right? If it had five in its longest chain, we would start by calling it pent, and then we would work out the ending, okay? So next is just to decide if there are any double or triple bonds. Easy enough. Now, if there is a double or triple bond, okay, we are going to change the ending of the name, but it's actually not quite enough. We also have to say where the double or triple bond is. If there is a double or triple bond, we're going to start counting the carbons from the end closer to this bond. So start counting closer to this bond. We're then just going to say which carbon it's on using a number between the prefix and the ending. So just indicate which carbon the double triple bond is located on by using a number in between the prefix and the ending, okay? So we always try to give it the lowest number possible. So always use the lower of the two numbered carbons. So for example, they gave pent to ene. So let's break that down. What does that tell us? Well, pent, what does that tell us? That tells us how many carbons are in the parent chain, right? So how many do you think that means? Well, if we go to check on our page 9, pent means there are 5 carbons in the parent chain. Okay, ene. What kind of, do you think this thing has anything besides single bonds? Yep, if it ends in ene, that means it has a double bond somewhere. Okay, and now what does the 2 mean? The 2 tells us where the double bond is. So pent to ene has 5 carbons with a double bond on the second carbon. So between the second and the third carbon, there's a double bond, okay? So really, what does this rule boil down to? It's stated in a lot of words, but really it's just saying make the double bond or triple bond have the lowest possible number when you're saying where it is, okay? Because you'll always have two options of where to start counting, okay? And then we use our ending. So if the hydrocarbon has only single bonds, it ends in ane. If it has a double bond, it ends in ene. And if it has a triple bond, it ends in ine, okay? So just to really quickly kind of summarize this, what does a name tell us? Well, we have a prefix, okay? And then we have the ending. And sometimes we have a blank blank number, okay? So prefix, what information does that give us? That just tells us number of carbons in, we call it the parent chain, okay? It just means the chain, the big, long, continuous chain of carbons, okay? What does the ending tell us? It tells us single, double, or triple bonds. So we're just writing down what information each part of a name gives us. Now, what does that number tell us? The number just tells us if there is a double or triple bond, where is it? Which carbon is it on? Okay, so which carbon the double or triple bond is on. If there is no double or triple bond, if it only has single bonds, then you can leave out the number. Okay, all right, so I'm going to make up some examples and we're going to think about what they tell us. Okay, so I've started here just by drawing a chain. Okay, now remember, every carbon needs to make 4 bonds. For this one, I'm going to make this a saturated hydrocarbon. In other words, I'm just going to have it have single carbon-to-carbon bonds. So that means I need to fill in all these spaces that are waiting with hydrogens. So there we go. Notice how now every carbon, if you look at each carbon, 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, 1, 2, 3, 4, they're all happy, okay? All right, so let's try and name this thing. So we've got how many carbons in our chain? Well, I see 1, 2, 3, 4, 5. So always circle the parent chain. It will just help you kind of cut out all the side information and focus on what's important, because all of the name actually just comes from what's happening with the carbons. The hydrogens are great, but they're just making the carbons happy. Okay, so 1, 2, 3, 4, 5 carbons in the parent chain. So remember, the number of carbons in the parent chain tells us the prefix. So what prefix matches 5 carbons? Well, pent, right? Pent matches 5. What's next? We have to say, are there any double or triple bonds? Do you see any? No, right? Single bond, single bond, single bond, single bond, single bond. So that tells us the ending. So this is going to end in what matches a single bond. Remember, in alphabetical order, single, double, triple. So this is pentane. And since there's no double or triple bonds, we don't have to say where they are, obviously, right? Because they don't exist. So this is actually good. This would be pentane. Okay, so just pointing out that there's single bonds only. Okay, I'm going to draw another one. Okay, now this time I've chosen to put a double bond in. Okay, still 5 carbons, but this now I've got a double bond. So be careful. Remember, how many bonds can every carbon make? 4. Okay, so this one has made 1. It's still waiting to make 3. I can fill those in with hydrogens. But look at this guy. It's already made 1, 2, 3. So it actually only has room to make 1 more bond. Same with this carbon. Look, 1, 2, 3. It only has room to make 1 more bond. This guy has made 2, so it can make 2 more. This one has only made 1, so 1, 2, 3. Okay, now I'm going to fill everything in with hydrogens. So again, we're going to start by saying, okay, how many carbons are there in the parent chain? And then we can use the prefix that matches. So look again, 1, 2, 3, 4, 5. Okay, so what's the prefix for this? Well, whatever matches 5 carbons. So pent. Okay, and then next we look if there are any double or triple bonds. Okay, so if there are any double or triple bonds, that's going to affect the ending of it. So looking here, yep, you betcha, there's a double bond right there. Okay, double bond. So what's the ending that matches a double bond? Well, ane for single, ene for double, ine for triple. So this is going to be pent something ene. Okay, and then remember, so we're done. Now we know, okay, it's a 5 carbon parent chain. There's a double bond somewhere. And what are you left dying to know? You're left to know, hey, you really want to know, where is that double bond? Well, because it could be on this carbon, it could be on that, right? Now we have to say which carbon it's on. And remember, we try to give it the lowest number possible, okay? So we could number them and say this is carbon 1, that 2, 3, 4, 5, okay? Let's just check the other way. If we go the other way, if we say 1, 2, 3, 4, 5, well, if we go this way, the first way I did, then the double bond is on carbon number 2, right? If we go the other way, then the double bond is on carbon number 3, right? So we have to give it the lowest number possible. So we're going to start counting from this end because 2 is lower than 3, right? So this is pent 2-ene, okay? We don't want it to be number 3. We want it to be on number 2 because 2 is smaller. You can probably guess what I'm going to do with this one. Okay, so now again here, I've started off by just drawing my carbons. I'll worry about hydrogens after. Okay, look at this carbon though. It's already made 1, 2, 3 bonds. It only has room for 1 hydrogen, right? This carbon has actually made 1, 2, 3, 4. It doesn't have room for any hydrogens. This guy's made 2. Same with this guy. And this guy's got room for 3. Okay, there we go. So let's name this thing I've made here. So we've got, again, always find that. That's going to tell us our prefix. 1, 2, 3, 4, 5 carbons, as we know pretty well by now. That means, okay, this thing's going to start with pent. Okay, pent means 5 carbons. Now, what's next? Look for any double or triple bonds. Do you see any? I sure do, right? Sticks out like a sore thumb. Triple bond. So that's going to tell us how it ends. So what's the ending that matches triple bond? Ane, ene, ine for triple, right? A, B, C, 1, 2, 3 in alphabetical order. Okay, so pentine. Now we have to say, where is that triple bond? Now we know, right? Pentine tells us 5 carbons and a triple bond, but we're left dying to know where the triple bond is. So I'm going to give you 2 options for how we could number this thing. We could say 1, 2, 3, 4, 5. And then the triple bond would be on carbon number 4, right? Or we could say 1, 2, 3, 4, 5. We can start at either end, okay? If I start at this end, this top way, it's on carbon number 4. If I start at this end, the bottom way, it's on carbon number 1. Which way should I choose? Well, I should make it be the lowest number possible, right? So I should start at this end and make it carbon number 1. So this is pent 1-ine. There we go. The name tells me everything I need to know. It's got 5 carbons. There's a triple bond somewhere. And where is the somewhere? Well, it's on the first carbon, okay? So I should go this way, not that way. Okay, just a introduction to what the idea of a condensed diagram is, because you might see it. So all a condensed diagram does is kind of take this big, kind of crazy to look at thing and just say, hey, just call it, instead of saying C with the 3 H's like that. So I'm going to just circle it. I'll erase it in a sec. But just say, okay, this whole thing here, let's just go ahead and say that's a CH3. So we have a CH3. You see how this is just this condensed? That's why it's called a condensed diagram, squeezed down to be a little nicer to look at. Then that CH3, what's it bonded to? Well, it's bonded to a CH2, right? So CH3 is bonded to a CH2, okay? Now what's that CH2 bonded to? Well, it's bonded to another CH2, right? A C with 2 H's. What's that CH2 bonded to? You guessed it, right? Another CH2. Finally, that CH2 is bonded to another at the end, C123, CH3. That's all a condensed diagram is. Okay, looking at the next one, it's a similar idea. What do we have here? Well, that's a CH3, but be careful, what's it bonded to? Not a CH2, it's only bonded to a C and an H. So CH. What's that CH bonded to? Now be extra careful here. That CH is double bonded to a CH, okay? So it's double bonded to a CH. So we do show the double bond. Double bonded to a CH, okay? But then from there, it's kind of business as usual. That CH is then bonded, single bonded to a CH2, single bonded to a CH2. And then that CH2 is single bonded to a CH3. Just condensed. We've taken this big kind of wacky looking picture and condensed it down a bit. Okay, next one. Finally, we've got, what do we have here at the beginning? This is a CH3, okay, single bonded to a CH2, single bonded to another CH2, single bonded to just a C, careful, just a C, right? There's no H's here, but then that C is triple bonded to a CH. So all condensed diagrams do is take these big things and squeeze them down a bit. So they're a little bit condensed. Well, that's what it means. They take up less paper, basically, okay? Realistically, we're always going to draw the structural diagrams, okay? But you might see these, so I just want you to have seen them before with me. Okay, last kind of way of representing it is the line diagram. So these are kind of like an even lazier option than the condensed. So we're just going to do the same examples. Pent-ane, pent-2-ene, and pent-1-ine, the same examples we've been doing. Okay, so these are just lines, okay? And the carbon atoms are at the end of each segment. So at the end of each segment, you have a carbon atom, but also at every corner. So basically, anytime it changes direction or ends, there's a carbon there, okay? We don't even bother showing the hydrogen atoms in line formulas. They're even lazier. One more point I want to say here is that double bonds and triple bonds are shown with another parallel line. I'll show you what I mean in a sec. Okay, so pent-ane. So at every end and every corner, there is going to be a carbon. So pent-ane, pent means 5, right? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I kind of always have to count it out in my head. It can be kind of tricky sometimes. So we got to count the number of carbons just to check our work. But this is actually already done. See how do I mean? That's kind of a lazy option. So what I mean though is here's the end of a line. So there's a carbon there. Then there's a corner. See how it changed directions? That's a carbon. Okay. Then there's another corner. It changed directions. That's a carbon. Corner, change directions, 4, and then it ends. So 5. So this is telling us there's 5 carbons and there's no double bonds. Hey, that's what pentane is. Pent, 5 carbons, ane, only single bonds. Let's try pent 2-ene. So again, 5 carbons. So 1, 2, 3, 4, 5. Okay, again, we have our 1, 2, 3, 4, 5 carbons. Okay, and then that's pent. Okay, we've dealt with pent, but what about the ene, the 2-ene part? Well, ene means double bond, and 2 tells us where it is. So on the second carbon, there is a double bond. How do we show that? Like this. Okay, why is this on the second carbon? Why didn't I go like that? Remember, if the double bond were there, the second one I just drew, well, then it would be pent 1-ene, right? Because we always give it the lowest number possible. So it's not there, it must be there. Pent 2-ene. Okay, that's all we do to show a double bond. Pent 1-ine, well, you guessed it, the 5 carbons. So 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, and then pent 1-ine. So on the first carbon, there is a triple bond. How do we show a triple bond? Well, if a single bond was 1 line, a double bond was 2 lines, you guessed it, a triple bond is going to be 3 lines total. So 1, 2, 3. We kind of make a sandwich with the main line, and that's pent 1-ine as a line formula. Okay, let's just get some practice naming these things with me. So what do we first kind of have to do? First things first, figure out how many carbons there are in the chain. So always circle it. It makes it easier, especially when we do branched. You'll be glad to be in the habit of circling, okay? So I see 1, 2, 3, 4 carbons. So go to page 9, find the beginning that matches 4 carbons. And you'll see there that 4 carbons means bute. That's the beginning we give it, bute. Okay, now are there any double or triple bonds? Because that's going to decide our ending. Do you see any? I don't. Okay, so single bonds only. What's the ending if you only have single bonds? Ane. So butane. And there we go. That's butane. Okay, the same as stuff that's in your barbecue lighters. Okay, next one. We got to find the parent chain of carbons. So I see, right, carbon, 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 no other carbons. So 1, 2, 3 in a chain together. Okay, so find the prefix, the beginning that matches 3 carbons. And you'll see that it is prop. Okay, next thing, to figure out our ending, do we have any double or triple bonds? You betcha, right there, right? That's a double bond. So this is going to end in what? Ene. Okay, notice I left a little room because what else do we have to do? We have to say where the double bond is. Okay, so we have 2 options for numbering this thing. We can go 1, 2, 3, left to right, or we could go right to left. 1, 2, 3. We can start at either end. If I start at this end, the double bond is on carbon number 1. If I start at this end, the double bond is on carbon number 2. So which option should I pick? I should pick the one that gives me the lowest number, right? So I'm going to do this one, not that one. So this is prop 1-ene. Last one for naming practice, we find the parent chain. So 1, 2, 3, 4. Find the beginning that matches 4, right? And we know from this one that the beginning that matches 4 is bute. So this is going to start with bute. Okay, next thing, are there any double or triple bonds? Sure thing, right there. That's a triple bond. So double and triple bonds tell us the ending. Okay, so this is going to be bute, and a triple bond gets the ending ine. Okay, last thing we need to say is where is the triple bond? So we could go 1, 2, 3, 4 and have it be on carbon number 1, or we could go 1, 2, 3, 4 and have it be on carbon number 3. Which one should we pick? Right, we should pick carbon number 1, right? That's way better. So this should be bute 1-ine. Okay, let's get some quick drawing practice with this stuff. Drawing is actually nicer because they can't trick you. So with the naming, they can kind of make it look a certain way. Since drawing, you're just going to take what they tell you and you're going to draw it the way you want. You can't really trick yourself as easily, okay? So remember, the beginning tells us the number of carbons, okay? And the ending tells us if there's any double or triple bonds. If there is a double or triple bond, the middle number will tell us where that is. So hept-ane. So hept tells us how many carbons. So if you look on page 9, you'll see that when there are 7 carbons, C7, it gets the beginning hept. Okay, so we're going to draw out how many carbons. Always step 1, draw the parent chain. Just like before, step 1 was find it. Step 1 when we're drawing it is to draw it. So 1, 2, 3, 4, 5, 6, 7. Just start by drawing it out. No triple or double. We can add those when we need to. Ane. So if it ends in ane, are there any double or triples? No. So we don't need to worry about even adding those. So now what's left to do? The last step is just fill in whatever's left with hydrogens. That's always going to be the last step. Okay, so we just have to make every carbon happy, and we do that with hydrogen. So remember, every carbon wants to make 4 bonds. So this guy's making 1, so 2, 3, 4. This one's making 2, 3, 4. And this one's making 1, 2, 3, 4. Okay, what is on all of those? Hydrogens. Okay, to practice the condensed, remember condensed just says, we don't need to see that carbon is, we know how carbon will bond to 3 hydrogens, so just say it's CH3, right? We know that if there's 3 hydrogens, it'll look like this. So we have a CH3, single bonded to a CH2, single bonded to a CH2, single bonded to another CH2. I'm just going to change directions because I'm running out of room. I'm allowed to do that. Single bonded to another CH2, single bonded to a 6th CH2, single bonded to a 7th CH2. Okay, notice I just turned because I was running out of room. You're allowed to do that. There's nothing wrong with that. Okay, now for the laziest option, the line diagram. Okay, so unless it asks you to draw the line diagram, you do need to draw the structural, but line diagram is good to know. So remember, at the corners and the ends is where you have carbons. So I need to have 7 carbons. That's step 1. So 1, 2, 3, 4, 5, 6, 7. Okay, double check my work because it can get hard to keep track. 1, 2, 3, 4, 5, 6, 7. There we go. And it's heptane, so I don't need to put any double bonds in or triple bonds. That's it. That's heptane. All right, hex 3-ene. So remember, hex tells us the number of carbons. Okay, the ending tells us any double or triples. So ene, that means there's going to be a double bond in there somewhere. What does the 3 tell us? It just tells us where that double bond is. Okay, so the number that comes before something is always, it tells us where that thing that's coming up is. Okay, when we get to branches, we'll use those numbers again. So hex 3-ene. So first things first, draw the parent chain. So hex matches, how many sides does a hexagon have? 6. Okay. First the carbons. Okay, so notice I've just drawn the single bonds because now I can go back and add the ene part. Okay, so on the 3rd carbon, there is a double bond. So 1, 2, 3, it's going to have a double bond. There we go. Okay, I don't put it here because that would be hex 2-ene, right? So hex 3-ene looks like that. What's left to do? Nothing. We've covered the hex, we've covered the ene. It's just time to fill everything in with hydrogens. So make every carbon happy. Okay, 1, 2, 3, 4. This one's making 3, be careful. So it only needs 1 more to have 4. Same thing for this one. 1, 2, 3, 4. Okay, to condense it, we just say what's going on with the carbons and the hydrogens. Don't worry about the shape. So CH3, single bonded to a CH2, single bonded to a CH. Careful, double bonded now to a CH. Okay, and then that CH is single bonded to a CH2. And then that CH2 is single bonded to a CH3. Okay, so there's condensed. Just takes up less paper, basically. For the line, every end and every corner represents a carbon. So 1, 2, 3, 4, 5, 6. Okay, double check. 1, 2, 3, 4, 5, 6. So that would be hexane, but we don't have hexane, right? We have hex 3-ene. Okay, so we need to add a double bond on the 3rd carbon. How do we show that? Boop. There we go, hex 3-ene. Okay, time for pent 1-ine. Pent 1-ine. So again, pent tells us how many carbons in the parent chain. Ine, the ending, tells us if there's any double or triples. Ine means triple. And 1-ine just tells us, okay, where is the triple? It's on the 1st carbon. So let's go ahead and draw pent 1-ine. Start with your 5 carbons. Just single bonds to start with, and then we can add the triple when we need to. So 1, 2, 3, 4, 5 for pent. Okay, now we go back and we can add the triple bond. Where does the triple bond go? Ine tells us triple bond. Where does it go? Well, the 1 tells us where it goes. So on the 1st carbon, there's a triple bond. There we go. Now, how do we finish this thing off? Make every carbon happy by giving it 4 bonds. So fill in with hydrogens to make every carbon happy, okay? So this carbon has 1, 2, 3, it only needs 1 hydrogen, and it's happy. This one has 1, 2, 3, 4, it actually doesn't want any hydrogen. It's already happy. 1, 2 bonds, so 3, 4, 1, 2, 3, 4, 1, condense it, so we have a CH triple bonded to just a C, right? So far I've drawn that part. Okay, single bonded to a CH2. Single bonded to another CH2. Single bonded to a CH3. Okay, so now to do the line diagram for pent 1 ion, well, pent 5 carbons, so 1, 2, 3, 4, 5, right? Double check, count them at the end, 1, 2, 3, 4, 5, there we go, we're good. And we need a triple bond on the first carbon. So triple bond, there's a single bond right now, that would make it a double bond, that makes it a triple bond, pent 1 ion. Okay, so that actually wraps up the kind of teaching part of the topic 1, okay, naming and drawing unbranched hydrocarbons. So that actually wraps up the topic 1 teaching part of the naming and drawing unbranched hydrocarbons, okay? I'm going to solve these in another video that would normally be whiteboard practice questions. So if you want, you can, I would say pause the video, try these out, okay? But I will post another kind of bonus video under the topic 1 that is just me solving these so that if you are struggling and you want to see some more examples, you don't feel great about this yet, you can watch me go through those. Just kind of extra examples for you to look at. At this point, if you're feeling good, go ahead and you can try some of the formative work for this topic. I will post in the Google Classroom and in the agenda which ones are a good fit to do now.